Bill, thank you so much for helping with my project. It's good to get to talk to you. I know you have a company, United Space Structures, which
Yes,
I'd love to talk to you more about, but could you give me a little intro and maybe background?
sure. Well, the ideas for United Space Structures actually started back in 1983, but I was way ahead of my time. So I tucked it in the back of my head and I waited, until a few years ago and I resurrected it. And about a year ago, October, um, I came up with a new idea and I presented it to a friend of mine who's a space architect. He loved it and got very excited. And we have been working on it for the last year plus. And so in July, I incorporated the company and have found some other world class partners to help build the company and make it what it needs to be. So that's we're in a fundraising situation right now. We're looking to find funding for doing our research and development to develop the robotics and the architecture and the engineering systems. That'll take about 6 years or so, and then after that we can start construction on the moon, and hopefully we'll be finished and ready to move in around 2031.
Well, that sounds really awesome, and yeah, I know there's a bit. So I guess how did you get into space? Um, what interests you?
Right. Well, I've always been very interested in design since a small child, and design of just about anything and everything. But I was especially interested in houses and buildings and things like that. So I went to school. I got a degree, a design degree, and went into the industry. And I started working at a mechanical engineering firm, and then I got another job, where I worked in electrical engineering and civil engineering and then architecture, and I worked my way up, and became manager and leader of other designers, and so I've seen all aspects of the AEC, the architecture, engineering, construction industry, and so I'm able to help the people I work with because I've done a lot of the things that they've done, and so I can anticipate what their needs are and help them so that they can move forward with their design ideas. So I've been involved with the AEC industry for over 30 years, 35 years, more than that. So and most of that time has been spent working in what they call the mission critical facility design. So mission critical facilities are facilities like hospitals and research centers and command centers and data centers, a lot of data centers that have to stay up regardless of what's happening, either naturally or man-made, disasters. So they have to stay up and running. So they're complex facilities that require redundancy of electrical and mechanical systems, and generally they're physically hardened to withstand earthquakes or floods or human attacks or whatever. So it's a complex kind of design problem, and I like that. I really appreciate it. So I've really never been involved in the space industry, although like I said, back in 1983 I came up with these ideas for these robotic systems for building large structures in the microgravity of space that are big enough to spin and create artificial gravity. I was following Dr. Gerard O'Neill's work back in the 70s and became very fascinated about how he would actually build it because it has large expanses of glass on his O'Neill cylinders. And I couldn't figure out, my background in design and construction, I couldn't understand how that was actually going to get built. So, so I came up with my own ideas, and it doesn't include glass, which is not a good insulator for radiation and things like that. But so I became interested in problem solving. And the way I look at design is I look at, the first principles kind of idea, in that, it starts with a process of how you build it, and that kind of dictates what you're going to build. Um, because the idea is to be able to, like, for instance, we're going to build, these large structures on the moon, but we're not going to send people there to do that work. We're going to teleoperate robotic systems, and so the system has to be simplistic enough so that a robotic system without humans around it can complete its task. So it starts with a process, and the process kind of dictates the architecture, and the architecture then dictates, how it's fit out finally. So, that's kind of how I work. Really doesn't matter what kind of design we're talking about. That's always the kind of process I go through.
It seems to me that it would be something difficult to get right the first time, and that you need a process where you can try something, see the effect of it, make changes, iterate, and kind of converge on a better and better solution. Um, Now, doing that the first time on the moon, um, it seems very expensive because the times you could iterate would be uh, like half a decade, between the time you've gotten something together, gotten into the moon, seen its effect, and then kind of recalibrate. But I was wondering if you had any thoughts on sort of testing this out here on Earth. It seems like there's a lot of places where being able to set up sort of remote habitats for people telerobotically, and then having people move in, test them out, would both kind of give you a chance to sort of prove out the technology in 1G and on Earth where it's easy to access it and iterate, and potentially a revenue stream,
Right.
um, before taking that same, and also giving lots of investors and people confidence that
Right.
you'll be successful. I was just wondering what your thoughts were there.
Yeah, no, you're absolutely correct. We're not going to test our ideas on the moon. It's no investors are going to put billions of dollars up in order to try something, right? So we're going to iterate. And unlike back in 1983, I mean, we had computers back then, but not like we do today. Not the power of computers and the graphics, and so we're going to start our iterative process, design process, through computer modeling and simulations. So we'll, without any cost or complexity in going to the field and doing something physically, we're gonna simulate the process in a computer very, very accurately, using physics, modeling, and things like that. So we'll be able to go through many different iterative processes, which is relatively simple process. I've made the construction process as simple as possible. So, we'll test all those systems out in a computer, and then once we've dialed in, what the requirements of the robotics need to be, and for them to operate, accurately, um, in the field, then we'll build them. We will send them to someplace here on Earth, and we will put them through their paces to be able to build a a prototype essentially here on Earth to prove that the process works. So yeah, that's something that we'll definitely be doing. We have a lot of work to do in the next 6 years. So um, we're gonna hit um, all those tests, and nothing's gonna get launched into space until it's ready to go.
I was wondering, in terms of software, is there off-the-shelf software that allows for you to do that type of simulation, or do you see something custom that you'll need to build?
No, there's plenty of computer aided engineering systems out there that will do this. So we don't have to reinvent that wheel. We just need to use that wheel. So, and we have to, hire the people that knows how to make the software work, and put it through its paces. Fortunately, the market has grown up quite a bit in the last few decades, to where we can get very sophisticated modeling and simulations, um, and an economical kind of way of doing it.
Any thoughts about maybe using the wisdom of the crowd and people's leisure time and what have you? It just seems to me that with like all these massive on-player, multiplayer games, you could almost see a situation where people have like the same physical constraints that you're dealing with, and they have to put together, what's the lowest cost, most versatile, best sort of habitat that's built on the moon using
Right.
maybe Astrobotics lander or intuitive machines, what they have available now, and then as new delivery services come on board, they could kind of be enabled in the game and what have you. I was just wondering if you had entertained any thoughts along those lines.
We are considering that. And when I mean that, one of the companies that we're working with, Precursor Technology, is doing our computer modeling, and they did the animation and all the images on our website. So they're very capable of doing this kind of work. And so we're talking to them about the potential of during the during the design process, we Space Structures would make make the models. I'm still getting some glare here. We'll make the models available to a certain degree to the open market, and encourage people to play with it. To come up with ideas about how we'll constrain it in that it has to be a cylindrical shape of certain size and diameter, that we're planning on designing, and certain configuration, structurally, and the core and things like that. But beyond that, we'll give them a kit of parts of objects that they can then put in the facility, and lay it out the interior of it, the way they think that they would like to have it. And so we'll try to build a community that hopefully thousands of people that come up with ideas, and if their ideas are good and we like them and they make sense, then we might just incorporate it in our design, and actually build it. So we'd like to build a grassroots movement. We want to get people engaged in the process, and so whether they want to go through a design process, with us, or they want to use our models to build a gaming environment, and then, utilize that gaming environment to then put it out to the marketplace so that they can get other people engaged in their games using our models, then, that's something that we're exploring.
And I know a lot of effort in the space community is put on engineering and transportation and the actual, physical manipulation of matter. But it seems like to me that there is a need to really deal with the human aspects of things as well. Living in a community on the moon, um, is going to be a lot different than living on the Earth. And, you know, um, I was just wondering what your thoughts were in terms of eventually once you kind of converge on the final design of actually figuring out who the occupants would be and kind of testing out to see if you got the right people um, to be part of that initial group.
The people who are going to be on the moon.
Right.
Right. So, we're looking for a variety of tenants. Uh, our company is really a real estate development company. We design and build and operate and own these facilities, and then we long and short term lease out these facilities to a variety of tenants who want to have access to the moon, either as scientists or as lunar miners, um, or as data center operators, because we want to expand the internet out throughout the solar system with communications and everything else, or tourists, who want to go to the moon and, be the first to, you know, have a vacation on the moon for a couple of weeks. So, we're looking for a variety of people. Now we'll also need staff that are going to be, maintaining the facility and keeping the clients safe and happy and productive and fulfilling their needs. So, there's the goal is to build this system, this facility, these facilities. We're going to eventually build hundreds and then thousands of them. But, the idea is to build them as self-sufficient as possible. So that we're growing all the food that is needed. You're not importing food. You're importing seeds and cell cultures for cell-based meat production and things like that, and we're creating our own energy, and we're going to use as much resources from the moon as humanly possible, and everything gets recycled and nothing gets thrown away. So it's going to take a different mindset, but the environment that we're going to build is going to be safe and secure and comfortable, and you'll have 1/6 of the gravity of Earth, but you still have gravity, and so there's duration of low gravity is a open question, and I'm sure biologists that we have come to the facility are gonna do testing of humans and animals and seeing what the long-term impact is to reduce gravity and things like that. But we're within a lava tube, and we've got 30 to 50 meters of regolith overhead. So and we chose the lava tube because it has that natural radiation protection that we don't have to build it in our architecture. So you're not going to have to worry about radiation unless or until you actually go out on the surface, and that's going to happen occasionally. But most of the activities, especially the lunar mining, that's going to be teleoperated robotics, uh, with people in our facility on the moon. And if they need to go out and they need to go fix something or study something in the field, they'll take a rover out and they'll do what they need to do and then come back. So there's people aren't going to go out on the moon and with pick and shovel and be mining. It's just not going to happen. So we have to consider the way uh, we operate is not going to be like Earth. It'll be similar, but not the same.
Yeah, my personal goal is to retire on the moon. And whenever I was reading through the United Space Structures website, the thought that kept going through my head is um, how to make you all more successful and make it happen quicker and more assured. I was wondering if maybe you could talk through some of what you see as being the roadmap from vision to a reality, and kind of how what are the opportunities to really help you get over those hurdles.
Right. Well, there's the research and development that we need to do. Some of that is relatively straightforward. The architecture and engineering is going to be very Earth-like. Has to hold an atmosphere and be thermally sound. But you know, that's a straightforward process. The robotics is a little more challenging, but we're hiring two of the best space robotic companies on the planet, and they're going to be helping us to build these robotics and test them and certify them and all that. So uh, the process of building on the moon is going to take a couple of years. Once we get there, then we'll be able to, build more facilities with more lunar materials. Um, and so the construction process will go faster. Um, we're right now anticipating, based on the costs that people are currently paying for space tourism. Uh, Jet, Richard Branson in Virgin Galactic, he's charging $250,000 for a 15-minute ride to the edge of space, right? And so the whole thing takes about 15 minutes. So if you put that out in hourly costs, that's $1 million an hour, or $24 million a day. So, and when you look at launch costs from SpaceX, you get a similar kind of metric. So that's what we're currently paying for those kind of services. You're not on the moon, but you're touching the edge of space, or orbiting space. Um, so what we're thinking is that, based on those metrics, if we reduce the cost, say for space tourism, to $1 million a day instead of $24 million a day, that's a considerable savings, and we think that there's a bigger market for that. Now it's still a lot of money, um, but using that metric, if we can, our facilities will hold hundreds of people. So if we have 100 tourists, each paying $1 million a night, and we book that, throughout the year, um, that's $36.5 billion a year just from space tourism. So these facility, and that's every year, right? As long as it's all booked. So we think that the return on investment is very enticing, because up until now, space has been something that's been done for basic uh, scientific research, and curiosity, uh, and or country showmanship. Um, and now we're talking about commercializing space so that space actually pays for itself. So once you build one and get up there and start using nearly 100% of lunar resources, the other facilities will go up very quickly, and will continue to populate the moon. So, having hundreds, if not thousands of these, and there's 62 known lava tubes. So having them built in, a normal lifespan is a real possibility, because the robotics are already there. The construction process has already been researched and developed. We're just going to be essentially replicating that process over and over again. So the initial cost of building the first one is going to get amortized into every subsequent facility. So
Yeah.
it becomes a lot less. Do you follow me?
We had a UPS guy drop off a package, so
No problems.
yeah, no, there's the first one's the hardest. Once you prove it out, it seems like the investment's easy to get, and kind of being able to scale it up seems straightforward. But I mean, you kind of face a believability problem of, can you actually build a space structure that humans can live in, and then will humans actually pay to get there? But once you've done that, then it seems like the follow-on is fairly straightforward. What kind of financing do you think you need in order to get to that first structure?
So the estimated cost today is around $3.67 billion. Um, as I said, that's just for the first one. Um, all those costs for the research and development, and the building of the robotics and launching everything. Once that's done the first time, then you don't have to experience that cost again. Now you'll still need to bring some things from Earth. Um, for instance, you need nitrogen. You and I are both breathing nitrogen right now, mostly, and there's no nitrogen on the moon. So we're going to have to, get it from Earth, send it to the moon, and fill it up. And fortunately, we can recycle that to some degree. Um, plants are also going to need nitrogen. So, there's certain things that are going to have to be brought in from Earth occasionally, but the idea is to make it as self-sufficient as possible with the resources, and that's a whole different mindset. Sorry about the phone.
Oh, no worries. Um, I guess $3 billion doesn't seem like a lot. Um, Especially considering like the human landing systems that they're looking at for Artemis are probably gonna total multiples of that. I was just wondering how do you get what allows for you to do it so much cheaper?
Well, again, we're not lifting the mass for our building from Earth and taking it to the moon. So we're using the in situ materials to to build the vast majority of the structure. We're just building the robotics, sending energy systems to be able to keep them powered, uh, to be able to communicate with them and teleoperate them from Earth. So it's uh, the beauty of this process is the simplicity of our design process. Um, if it were super complicated, that would be one thing, but it's not. It's relatively simple, straightforward process, and so we're gonna test it out vigorously here on Earth, and then once we feel confident that it can work reliably, then we'll send it up.
Does that mean like having robots that are looking for specific types of rocks and then picking them up and putting them into a smelter of some type to, uh, you know, produce the raw materials that you would use to build the facility? Is that kind of like what you're thinking? I mean, how
Yeah.
would it work?
So so the way our process works is we we build a tension structure within the lava tube vertically from the floor of the lava tube to the ceiling of the lava tube, and so we bring the initial structure is going to bring some basaltic cables, woven cables that are very long, and we're going to bring those from Earth and bring them to the moon. We're going to drill holes from the surface down through the regolith until it comes out in the top of the lava tube, and then we're going to string those cables down to the floor, and we're going to secure them, and then we're going to put them in tension, and then around those cables we're going to spin some additional cables and some lath material. And so once you have this tension structure in place, then you're going to have a lunar crate, which is waterless. So it's not a chemical reaction; it's actually a heating process. So there's two different chemicals that we need, and they're readily found on the moon, and they're located in the locations near these lava tubes. So we'll go out and gather those and refine them and mix them, and then we'll move them down from the surface down into the lava tube, and we'll start at the base on the inside, the outside of the tension structure, and we'll start, essentially melting this material on either side of the tension structure so that it incorporates that tension structure and beyond, outside of it. And so we'll just continue that essentially, 3D printing process um, all the way up to the top until we can seal it off. So once you have it all sealed up and you have a center core put in, which will probably happen even before the tension structure goes in, and you seal it all up, then you can add an atmosphere and you could heat it and light it, and now the vast majority of the fit out for the interior of it can be done in short sleeve environment. So people, astronauts, you know, construction workers will go there, they'll get out of their suits, and they'll continue, building and fitting out the interior of this structure. So that's the process we're going to go through. Um, and I've tried to make it as simple as possible. I mean, it's not going to be easy, but it's not going to be impossible either. So it's a journey that we're all going to go on.
And how critical is the 2024 moon landing to sort of your timeline and your vision and your company?
You mean for the Artemis?
For Artemis, yeah.
Yeah. Obviously they've got their hopes and desires, and the scale that they want to do, and their timeline is much smaller, and um, it's just less than what we're planning on doing. We're several orders of magnitude larger than what they're planning on doing in their time frame. Um, but we actually want to conduct a between 1 and 3 robotics survey missions around 2023. And if we need to work with some Artemis, partners, um, then we'll do that so that we can get there and send robotics into the lava tubes to be able to scan it, make sure that we know what we're building to, right? Because nobody builds a building today here on Earth unless you have a geological report, and do you have enough vertical height or width, or where's your property? And we don't have those kind of constraints. But if you're building within a lava tube, right now we're assuming that it's going to be 100 meters tall, from floor to ceiling, but it might be bigger than that. It might be smaller than that. There's going to be some of these lava tubes can be tens of kilometers long. So, finding the right place that's stable, geologically stable and desirable, that's what we're going to be doing. And then, once we get there and set up shop, we can, instead of being basaltic cables from Earth, we can, lava tubes are essentially made out of basalt. So we can mine the basalt, basalt within the lava tubes on the moon, and then manufacture that into braided cables for the future facilities. So, you know, every step we take in building out these facilities, and reinforces our ability to mine and manufacture and build more and more of these facilities. So it'll increase in time.
That makes sense. And um, I mean, what is it seems like, uh, how do you deal with governmental entities and things like that in terms of this will be the first time that such a structure would have been built? Um, what does the regulatory process look like?
Yeah, that's something we have a space lawyer who's very familiar with that. A lot of countries, not all countries, but a lot of countries have signed the 1967 Space Treaty Act. Um, and in that act, it very clearly indicates that countries cannot claim property in space, but it doesn't say anything about corporations. And since USS is not a country, we're a company, we're feeling fairly confident, especially since President Obama in 2015 and then President Trump in 2018 signed executive orders, indicating that at least Americans should have the ability to go there and occupy space on the moon or wherever, and be able to do mining or operations or whatever. So the at least the United States federal government has already kind of indicated that they're interested in allowing companies to do that. So so it could turn out that countries are going to be dependent on corporations um, to do their bidding essentially in space, right? Because if these countries can't own property in space and control it through that ownership, then they're going to have to work through possibly corporations that can, right? So it's kind of a murky area, but we think that, especially since there's no inhabitants on the moon that anyone knows of. Um, and so you don't have to buy the land. You don't need to get permission. You don't have to do zoning. You don't have to pay the local taxes. There's a lot of things that you have to do here on Earth that you're not going to have to do on the moon. Um, Now, are people going to be outraged here on Earth that, we're tearing up the moon and all this other stuff? Possibly. I mean, you're always going to get some people that say, leave it the way it is, I guess forever. I don't know. But, we as a species, we started in Africa, and then we went north, and then we went east and west, and we spanned the globe, and we've been everywhere, and we're spreading everywhere. And now, we're spreading out into the solar system. And so, it's inevitable that humans are going to continue to do that, um, because we're curious, right? We're endlessly curious about what's over the next hill.
Yeah, it was really surprising to interview some people and for them to say, we shouldn't go to the moon because we messed up the Earth. Why mess up the moon too? And it's really difficult for me to kind of understand that perspective since, I think of pollution in terms of its impact on life, and the moon is seen as being kind of lifeless and just a rock. So it's like, how could you possibly mess it up? Um, but it kind of stimulated my thinking a little bit in the sense that maybe there are some actions that could be taken on the moon that limit our future activities. And I think about like volatiles, for example, that might be trapped inside of these lava tubes that once you kind of like drill into them and open it up somewhat, but potentially you could start a situation where they start escaping and it kind of what have you. And I mean, eh, maybe you do have to mess up a few to get some of them right, but I was just wondering, kind of like what your thoughts were along those lines of, this has never been done before. You're going to learn things in the process. How do you sort of keep the project on track, but at the same time take into account the things that you learn?
Right. Well, we're a very wasteful species. We were born on a paradise, the Earth, which you can walk around naked, and you can pick food off the ground, and you have everything, right? And space doesn't give you that. You have to recycle everything. It costs way too much to be wasteful in space. So our mindset is going to have to be completely different. And we're not going to be burning oil or coal or whatever. So you're not going to be polluting the atmosphere. Um, Now, you do want to be able to utilize the resources on the moon, the metals and the minerals and so forth, and the water, to be able to uh, build other structures in space, because you're not going to lift, um, mass off the Earth and build structures in space. I mean, like the ISS. That was a $150 billion process, and it's a very small structure that only holds about half dozen people at a time. So, if you're going to think bigger and longer term, then you need to get resources from the moon and manufacture, space stations and spaceships and things like that. And right now, they want to mine water on the moon, and part of that's going to be for human use, and part of it's going to be for rocket fuel. They're going to subdivide that water into hydrogen and oxygen and recombine it again to make it a fuel. And in some respects, I'm I I I don't really like that process of just burning that fuel, because it could be used for human use. It could be used and continuously used, recycled, for human use, or it could be used as a radiation protection for future spaceships and things like that. So, I'm hopeful that, futuristic propulsion systems like fusion fusion rockets, um, which have different design constraints than a fusion reactor for energy here on Earth, uh, which is much more complicated. I'm not saying fusion rockets are simple. It's just that it's a different problem, and it's achievable, because you want things to go out the end, right? It's just controlling that process. So we're going to need to utilize the moon in order to expand out, and the idea is to not waste anything. You're gonna use everything. Um, and one of the other things that's on the moon that might help us here on Earth, again, once they get fusion reactors for creating power working here on Earth, one of the best fuels is helium-3,
Hmm.
and it's a very, very rare thing on Earth. It's really only something that's created in cyclotrons and other kind of nuclear reactions, but very small amounts. So if you want larger amounts of helium-3, you want to go to the moon, because it's 1 part per million of the moon. Um, and that seems small, but it's much, much greater than here on Earth. So, you know, it's been it's been thought that you can power the entire planet of Earth, everyone, all countries, um, using using fusion reactions. You can power the entire planet for a year using 5 tons of helium-3. So, if we mine helium-3 on the moon and bring it back here to Earth and put it in our reactors, now you're now you don't have to depend on any nuclear, fission reactions. You don't have to. I mean, I'm all for renewable energy, totally, but you're not going to be, burning oil and gas and coal and all this other stuff. And so, pollution can be resolved, and you can run an electric-based um, economy. So, I think there's a lot of pluses, for the Earth if you can utilize intelligently, responsibly, the resources from space. It can bring riches to everyone on the planet.
Yeah, but even barring helium-3, which I think is largely theoretical right now, isn't it? As we don't quite have the reactors for it, and we think it would be, but solar power is something that's sort of proven out, and it's kind of an interesting intellectual exercise to think of. Only 1/700th billionth of the sun's energy actually falls on the Earth,
Yeah,
and just what kind of scale that is, in terms of uh, civilization could have unlimited energy, build solar panels on the moon and launch them into space in orbit around the Earth, and
yeah,
um, getting the power down to the surface is the big challenge. But maybe you use it in space like you are talking about on the moon, like data centers and manufacturing and other types of things.
right. Well, solar energy is definitely desirable, um, but to understand, solar use on the moon, um, you need to understand that the moon is tidally locked to the Earth. So we're always seeing the same face of the moon, regardless of where you are on the planet, right, on Earth. And so because it doesn't spin on its axis, um, what you have is 2 weeks of lunar night and 2 weeks of lunar day. So the question is what do you do for power in those 2 weeks where there's no solar power, right? So you're going to need some sort of nuclear reactors, especially when you're requiring megawatts of power for data centers. You're going to need that. Now, am I for space platforms in space? to generate power and beam it back to Earth? Yes, it's really a question of economics, right? And again, if you start with building materials from the moon, you can launch 6 times more mass off the moon than you can off the Earth for the same amount of energy. And so it only makes sense to use those resources to then make those solar panel systems in space and then beam it back to Earth. I've talked to several people who have been looking at that for decades, and it's still very much a viable possibility. It's an economics thing, and we, as a species, we tend to look at the lowest cost and focus on that instead of what the longer term operating costs are and benefits and things like that. So again, our species is very short term thinking. We need to think longer term, um, but hopefully we'll get there.
One of the people I was interviewing was talking about the Long Now Foundation. I don't know if you heard about them, but one of the proposals he was saying that they had was if we just simply put a zero in front of the year, at least that starts stimulating the thinking that there's a lot more time ahead of us. Instead of 2020, 2020.
Right,
Uh,
right.
so I thought that's kind of a neat idea. Um, yeah, and I mean, we even have trouble keeping the space program on track for 4 years or longer. So it's kind
Yeah.
of uh, hard to have a multi-decade plan that keeps getting shifted around. Um, Most of the people I've talked to that aren't in the space community have no clue that we're going to the moon, and I was wondering if that surprised you.
No, I run across them also. They think of it as science fiction, and and part of the problem is that we we were last on the moon around 50 years ago, right? We first stepped on the moon 50 years ago, and we really haven't been back since the 70s, since 1972, I think it was. So people look at all those 50 years, and we haven't gone back. There must be a reason, right? Well, it's an economics thing, and countries just can't put up that amount of money for that long to be able to, for no payback. Countries don't. They they again they focus on the science. They're not thinking about the economics of it. It's just not their mandate. They're not a corporation. So I think when private industry gets involved, then you're going to have a space economy uh, that feeds itself and perpetuates itself. Um, and so I think people will wake up eventually, but right now most people are just focused on here on Earth. They're worried about the pandemic and whether they can go out and eat or buy toilet paper or whatever it is. They're 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 very focused. They're looking through a microscope, and they're not seeing the bigger picture. So the light bulb will go off. But that'll happen once you start sending missions to the moon, and especially when you see people walking on the moon again. I mean, it'll become more real because it's been what, 2 generations since people walked on the moon. So my generation saw that. My kids didn't. I mean, they love space and stuff like that, but they didn't watch the whole thing unfold in the '60s, with it ending, with guys walking around on the moon. So it's not in their gut, right? It's not their mindset. But once that happens again, you're gonna see a shift in people's thoughts, I think, and excitement levels, and hopefully people use that excitement to learn more STEM education and learn how to participate and get involved, and think that they could be involved, right? I mean, right now, you know people probably think that they can't, even though whenever NASA puts up applications for astronauts, they always get literally tens of thousands of people applying. They're only looking to fill 20 or 30 seats, and so there's a lot of interest out there. It's just that um, it's not everybody, right?
Indeed, and I was wondering if that might be the dependency on Artemis. I mean, once you start having those photos of people walking on the moon again, and it's in 4K, and these are people that are actually, just back from the moon, visiting. If that becomes like a turning point for your project, of people going, oh, people can be on the moon and survive, and it's possible, and this is just scaling it up and doing it a little bit different.
Right. A validation of the idea. Yeah.
Yeah.
Yeah. I think I think that'll happen. Uh, so, but the problem right now is that the Senate, the U.S. Senate, which is Republican based, um, they essentially shorted NASA's budget by, I think it was $2.5 billion, and those $2.5 billion were needed for the launch capabilities to be able to land, either equipment or people on the moon. And so without that budget, question is, what's actually going to happen in 2024 if they, you can go to the moon, you can go around the moon, but now you can't land on the moon because you haven't put the budget in place to do that. So I don't know. It's still up in the air. The problem with NASA is they're a great organization. I mean, for the return on investment, there's no other government agency that's been able to have return on investment unlike NASA. I mean, they've created this technology that we're working with right now with the internet and computers and cameras and eh, lots of technology that they've created, and now we all just take it for granted. Uh, but the problem with NASA is that they're a political football. Their focus changes every 4 to 8 years when a new administration comes in. So, we don't really know what's going to happen in the new Biden administration because, they're obviously going to be focused here on Earth and with people and recovery and COVID and, jobs and all, bailouts and all this other stuff. Uh, but, we also need to keep one eye to the sky, to the future. And so the question is, if NASA is getting batted around every 4 to 8 years, you can't have an intelligent long-term project get funded if the ideas change every 4 to 8 years. It's just these projects tend to be bigger and very expensive, and so you need a consistency in funding and vision. And I don't know how to do that politically. I mean, it's just, again, it's a political football, and I hate to see NASA be put in that position, but they're at the will of the government to be able to fund them. So I don't know. So I'm hoping that private industry, like my company and others, are going to take up that mantle and you know uh, continue to do those things in economical ways so that we can get to where we want to go and do what we want to do. Right.
Yeah, and I'm wondering if international agreements and partners kind of assist with that continuity. I mean, you look at ISS, that's been a program. I mean, it really got started back under Reagan, kind of really under construction with Clinton. And then, of course, it's been persisted through the Bush and Obama and the Trump administrations. And a large part of it is, it's not just us. I mean, we have the Russians and the European Space Agency, the Canadian Space Agency, the Japanese Space Agency, and
Right.
I mean, we're kind of all holding each other accountable, like some type of arch where it's like,
Yeah. Yeah. I mean, no one country could probably take it on. I mean, um, fiscally, it's difficult. So sharing that burden with others is an important step. And of course, what they get in return is the knowledge, right, of doing it and operating it, over time. And so, we've in getting this ball rolling, we've brought other countries engaged in the process so that now, they can go and do their projects uh, on the moon or Mars or wherever they want to go. They had a foothold based on the ISS. But the ISS, I think it was only supposed to last 15 years. The
Hmm.
design components in the ISS are only, individually rated for 15 years. And we've been going for 20, and now we're talking about pushing out to 2024. So now you're talking about, 10 years potentially over, or 9 years over its design capability. Um, and maybe that's why we're seeing, holes pop up in the hull of, I mean, it could be, meteor strikes or something else, but you know, these systems can't last forever. And so building structures that only last 20, 25 years, um, um, and costing $150 billion, and only holding 6 people, that's that's just an unworkable long-term solution, right? But it's a test, right? It's an idea of what we can do. Well, now that we know we can do that, and we've learned that the microgravity of space is harmful for humans, um, the next step is we need to build a larger space station, and we need to use lunar materials, and we need to spin that and create artificial gravity, uh, and shield it well, so that it can stay in orbit, or move between the Earth and the Moon, or the an Aldrin cycler, which is a continuous ferrying system between Earth and Mars. In which the cycler never stops. Right, once you launch it and get it on its right trajectory, it swings by Mars and then cycles back. And so you spend fuel once, maybe corrected occasionally, if you're a little off kilter. But otherwise, you're not spending any more fuel significantly to go back and forth between Mars. Now, the trip will take 2 years. You have to have it safe for people and microgravity and radiation and all that. Um, but those are all things that can definitely happen. It's just a matter of having the will to want to do that, right? And that's what we need to now do, is we need to push ourselves to figure out what we want to do and why we want to do it, and why it's important. And so we're still discovering that. We're still working on uh, coming up with those ideas, and making them happen.
And I don't know if you remember the 1990s with regards to internet and computers. I think in 1990 you probably had an easier time explaining why astronauts float to somebody than what email and web shopping was. But by 2000, everybody had email. Everybody knew what why a web, shopping online was, and what the web was,
Right.
um, and I feel like that between like SpaceX and Blue Origin and NASA and the commercial lunar payload services companies, and what you see China doing, and what you see people like you doing, I really feel like that the 2020s might be as transformative for space exploration as the 1990s were for internet and computers. And
Yes.
I was wondering if you've felt the same way, or if that may be
Oh,
overly optimistic.
no, I think it's definitely going to happen. And again, it's not because there are countries. I mean, China is pushing the envelope. Europe wants to build a facility on the moon. Um, Russians are still involved. They're going to be working, I think, with China on another space station. Um, so I see a lot of things happening through countries, but I'm also seeing a lot of private companies starting up and building things, and for space, and so we're not alone. And it'll create a momentum in the marketplace, and investors will finally see there's an opening for making money through a space economy, and so they'll start putting money into the process, and things will grow, and some things will fail, because that's how they that's how we learn. You fail, and then you fail until you run out of money, and then you fail altogether. But if you can like Elon Musk, he launched 3 rockets with his own money, and those all failed. And he had just enough money to launch his fourth and final rocket. And fortunately, that one worked, and they figured out, how to make it work. And so now he's launching practically every week, sometimes twice a day, and we take it for granted, but it used to be impossible. Now it's oh ho hum. What else is new, right? So we'll get over this hump. It it will be transformative in the next 10 years. You'll see so many different people getting involved in doing these amazing things, and it'll light people up. I think it'll really engage, especially young people. I think it'll really get them going, which is good.
Yeah, I mean, I think space provides like a social safety valve. Even though only a very small percentage of humanity will actually go to space, just the knowledge that some people get to might help to relieve some of the pressure here on Earth. To kind of know that you're part of a society or civilization that is actually growing in that way. Um, I,
Well, our goal is to really build, literally 1,000 or more facilities on the moon that'll hold 500 people or more. So,
oh, wow.
the idea of having 500,000 people on the moon is a real possibility, and it's going to happen within decades and not hundreds of years. And if we could do it there, we can then go to Mars and do that there. I know Elon's very excited about doing that. If I can help him, that's great. But we're gonna build architecture everywhere we can that people want to pay to be able to go and do and be there. So we'll make it happen.
Yeah, and once you have the people on the moon and you have that infrastructure in place, a lot of things become so much easier and cheaper. I mean, now you have to, I mean, even like the internet. I mean, in like the 1960s, if you even had today's technology, it would be impossible to create the internet. You just have two computers hooked up to each other, and it's like the network effect, right? I mean, once you get,
Right. Yep.
uh, so,
Exactly.
if it was safe and affordable, would you go to space?
Oh, I'm planning on having a place on the moon. Um, I mean, I'm the CEO of the company. I'm gonna be running this and building many of them. So yeah, I definitely would like to go. And so going to Mars, I don't know. Who knows? We'll see what happens. There could be new propulsion systems that come out that allow us to get there quicker and easier, sending more mass there and all that. But we want to take baby steps, right? And the moon is our closest baby step, and and it's a good proving ground for everyone to see how their systems work in the hardness of space. So once we figure that out, then we can replicate that and go further, right? So
Yeah, it's not a given that being the CEO of a space-related company would want to go. I know back whenever Dear Moon was announced and the Japanese billionaire was like talking to Elon Musk, it's like, hey, you should come with us. He's like, you're a brave man. You're a very brave man. You need no commitment whatsoever.
right, right.
uh,
Well, the most dangerous thing about going to the moon is taking off and landing, right? Once you're there in a safe facility, then it's like sitting in your living room. I mean, it's really not going to be that much different. Uh, you're going to build N+1 redundancies in your electrical and your power and your heating and air supply and all those things. So yeah, once you get off the off the rocket and in our facility, you're going to be fine. The idea is to make it safe. You know, the idea of architecture is to not just build a structure, but to build a structure safely so that people can live in it without worrying that it's going to fall on them. Right? You're trying to get out of the elements, not create create problems for yourself. So the same is true for, building in space. You want to build the safest potential structures that you can so that you can continue to be there and stay there.
Yeah, I think you make a good point that your biggest risk is about takeoff and landing, but once you get there, I would kind of argue that your biggest risk is other people taking off and landing. With the that could be especially on the moon where you don't have the atmosphere kind of slowing down particles, and the abrasive rock and dust and what have you that literally depending upon how we go about landing and taking off on the moon might actually envelop the moon in a cloud of orbital debris.
Right. Well, when you first land there, you're not going to have any landing pads, but the idea is to build landing pads. Um, so you're not kicking up, lunar regolith all the time. Um, but then you're also going to have your landing pads at a certain safe distance away from your facility. And you're probably going to have berms around the launch pads so that if there is anything that's loose, that it's not getting, kicked to the other side of the moon, right? So, there's ways of mitigating some of these issues. It'll take time, but building a launch pad is going to be a critical first step.
That makes sense. Well, Bill, I really appreciate your time, and I'm really excited to see about what your company is going to be doing and everything. Um,
Yeah.
is there anything that you wanted to talk about that we didn't get to?
No, I just want as many people to know that this is coming. It's going to happen, and the goal is to make it possible for everyone and anyone to go to the moon to visit or to work or to play or whatever. So, I just want to let people, go to our website. It's united-space-structures.com and look at what we're planning on doing and where we're planning on going and what our architecture looks like. There's a 60-second video that if you want to, explore the building somewhat and what's going to be in it, it shows that and shows our partners and where they came from and where they're going. And so, it's there's a lot of interesting information. And so if you're just hearing about this now, this is going to impact you in the future. It's definitely going to happen. So stay tuned.
When people hear about impact and rockets, you don't want them to get the wrong idea.
Right, right. Well, as long as as the impact is gentle and soft and you can walk away from it, it's always a good landing, right?
That's right. That's true. Well, um, I'll let you get back to building the moon base, or at least the company that's building the moon base,
Yep,
and I hope to cross paths again, especially after this COVID-19 thing's over.
that'd be good. Where are you located?
Houston, Texas.
Oh, okay. Well, that's where my space architect is and his project manager there in Houston.
Oh, wow. I should connect with them. If
So look up Chris Kennedy on LinkedIn.
okay.
There's also Spencer Stanford. I'm sorry, Stanford. Chris is his profile is on the website, but he's also found on LinkedIn. Um, and then Spencer, you could probably just look up Spencer Stanford on LinkedIn and find him there. So yeah, they're all local. Chris worked at Johnson Space Center for 30 years. He's seen and designed everything that NASA's been doing for the last 30 years. So
Did they go to I know the University of Houston has a master's program in space architecture. I was wondering
Chris
if they're,
actually teaches there.
oh, he does.
He's
Awesome.
one of the professors, and he taught Spencer at that university. So yeah, I mean, Chris is a great guy. You really ought to get together with him, see if he wants to do an interview. He's got his own space design company in addition to being, a partner in our company. But he's a great guy. He's an amazing guy to work for. So I would definitely look him up and let him know that we've chatted you want to interview him, he might just go for it. Who knows?
That'd be awesome. And also we have a local chapter of the National Space Society that I'm part of, the North Houston Space Society.
Uh-huh.
So maybe I can get him to come up here and speak whenever we start having our monthly in-person meetings again.
Sure. Yeah. I mean, I think he's supposed to go talk to some other university in another state or something. And again, because of the COVID, he may be doing that remotely. Everything's a Zoom call now, but yeah, get a hold of him. He's a big advocate for space, so check him out.
Awesome. Well, thank you again so much, Bill, and have a good rest of your day.
All right. Thank you very much. Have a good day.